Okay, so this lesson is on solving logarithmic equations. So we've seen how to solve exponential equations, and now we're going to see how to solve some logarithmic equations. And essentially there are different techniques you would use to solve different logarithmic equations. So let's take a look at the warm-up. So it asks us to solve the following equation, and I recognize that this is an exponential equation since the variable I'm looking for is in the exponent, so I know it's an exponential equation. And so if you think back to how we solve exponential equations, we would take the logarithm of both sides in order to apply the power law of logarithms and bring the exponent part down. Okay? So I'm going to take a log of both sides. And I get the log of 7 to the exponent x plus 2 equals a log of 100. And I'm going to apply the power law here to get x plus 2 times the log of 7 equals the log of 100. And now to isolate x plus 2, my goal is to try to get the x by itself. I'm going to divide both sides by log of 7 so I can eliminate that from the left-hand side. And I get x plus 2 equals the log of 100 divided by the log of 7. And in order to simplify this completely, I need to move the 2 over to the right-hand side. And I get x equals log of 100 over log of 7 minus 2. So there's the value for x. Okay, so that was a quick review of solving exponential equations. Okay, so before we move on to solving logarithmic equations, just a few things for you to remember. So recall the laws of logarithms. First of all, in order to use any of the laws that we're going to be looking at, the bases for your logarithms have to be the same. So they either have to be both a base of 2 or a base of 3, a base of 10, whatever they are, they have to have the same base. So here's the power law. So remember that the laws of logarithms are related to the laws of exponential expressions that you looked at from grade 9. And so when you are multiplying a power of a power, when you have a power of a power, typically what you did is you multiplied the exponent. So if you look at the power law, essentially what you're doing here is you're taking the exponent of the answer part and you're writing it as the coefficient of the logarithm, and that's the power law of logarithms. And so basically what you're doing is you're taking the exponent that you had on the power and you're multiplying it with the logarithm, which also represents an exponent. So you're actually multiplying two exponents together here. Okay? The product law looks at multiplying powers with the same base, and typically what you did when you were looking at exponent rules is you added exponents. And so the product law, whenever you have the log base b of m times n, you can actually add the log of base b of m plus the log base b of n. Okay, same holds true if you're going backwards. If you have addition between logarithms that have the same base, you can multiply the power part. Okay, the quotient law, whenever you're dividing powers with the same base, you would subtract the exponents. A logarithm represents an exponent, so you can subtract them in order to separate the quotient here. Okay, or if you're subtracting two logarithms with the same base, you can write them as division instead. Alright. So a few more things for you to remember. When you're solving equations in general, first of all, when you have an exponential equation, one of the ways of knowing that it's an exponential equation is to recognize that the variable is part of the exponent, just like we saw in the warm-up. So to solve an exponential equation, the easiest thing you can do is apply a logarithm to both sides of the equation. So like the example we saw in the warm-up, if you apply a logarithm to both sides of the equation, what you can do then is apply the power law of logs to bring down the exponent parts. Okay? The other thing that we're going to be looking at, and this is our focus for today, is solving logarithmic equations. And so in a logarithmic equation, the variable you're trying to solve for is part of the logarithm. Okay, that's how you know it's a logarithmic equation. And so to solve a logarithmic equation, we can rewrite the equation in exponential form and then solve the resulting equation. We know how to do this from once it's an exponential equation. So for example, if you had log base 6 of x plus 5 equals 2, you can rewrite this in exponential form as 6 to the exponent 2 is equal to x plus 5, and that's essentially what we did down here. Okay, so when you're solving a logarithmic equation, your goal is to eliminate the logarithm, and so in order to eliminate the logarithm, you have to rewrite it in exponential form. Okay, so when you're solving logarithmic equations, there's one property that you may see often, property you're going to be looking at is when you have the log base v of m equal to the log base v of n. So essentially you are looking at the log of two expressions, one on the left side and one on the right side. And if you're looking at the log with the same base, then that means that the expression m has to be equal to the expression n in order for the statement to be true. Okay? So if you have log base v of m equals log base v of n, that implies that m is equal to n. Okay, so this is one of the properties that you may find useful as you're solving logarithmic equations. Okay, we may also need to use other techniques for solving, such as factoring or using the quadratic formula as well. So those are some things to keep in mind. You may end up getting a quadratic equation that you may need to use the quadratic formula for, or to solve using factoring techniques. Okay, another key thing is to remember is that oftentimes you may get an extraneous root, and so some algebraic methods may lead to extraneous roots, which are solutions that are not valid to the original equation. So for example, you may end up getting something like 2 to the exponent x equals negative 3, and we know that there's no value of x that will ever make the statement true. No power can ever give you a negative result. Okay, so those are some of the things that we know will lead to an extraneous root. That's for exponential equations. For logarithmic equations, if you have something like log of x equals some number, and the value of x that you end up solving for is x equal to negative 3, for example, this is also an extraneous root. And the reason why this is an extraneous root is because a logarithm is only true for values of x that are greater than 0. So you can only have positive values of x. So that's something else for you to look at. This is also an extraneous root because log of negative 3 does not exist. Logarithms only exist for values of x that are greater than 0, so only positive values of x. Now, please be careful. Just because the value of x is negative doesn't necessarily mean that it's not true. It all depends on the expression that you have here and what the value of the variable is that you solve for. And so we're going to look at different examples where it may seem that the solution is not reasonable, and then you might find that it actually is. Okay? So those are the kinds of things that we will be seeing shortly in the examples.